Continuing with the problems that we would like to come across in real-world setting, in this module, we shall look at a real-world network with the devices connected. So we are going to understand the effect of deployment of various devices in the departments. We are going to look at the effect of the protocol behavior within such deployment. The traffic that goes through these network devices is greatly affected by the queuing behavior of the network devices. We'll see that as well. And finally, we'd look at the considerations for network design. When you have gone through these problems, you would understand how to interpret the topological connectivity, the presence of devices, their behavior, in overall assessment of the goodness of that network. Let's look at the network first. Here, you can see that we have an enterprise network in which there are different city offices, also called branch offices, which are connected to the data center shown to you in the center of the figure. Various devices such as core switch, access switches, and routers are shown here. The transmission media which connect these networking devices are shown with respect to their data rates. Also, you can see that the data center has access to the core network, which offers services such as file transfer protocol, access to the internet, and high-end computational servers. If you want to understand what is the effect of the deployment of these devices and the overall protocol behavior, you must be able to understand and comment on some of these questions. For example, can you see the data center here? Where is that placed? For users coming from the Eugene network, what is the data rate available to them? What is the maximum internet speed which is available to all the users? You should also be in a position to label the routers which must implement firewall. And you can look at a scenario in which if there is a user in Medford city, if it sends a broadcast, what is the impact? So this will give you a fairly good understanding about the behavior of routers, the behavior of switches. So when you are modeling them, you would understand that the intuitive sense should not be violated by the simulation behavior. For the internetworking devices, queuing behavior has a very important role to play in serving the users. Let's look at this scenario. If there's a Cisco switch with 20 users, which could be either clients or servers or both, if each is offering packets at a rate of 200 packets per second, and if the average length of the packets is 64 bytes, which is the smallest packet of course, and the transmission rate is 10 megabits per second, can you mathematically determine the load of all the users aggregated and it's the LAN utilization? And with this utilization, can you give the queue depth? Then you should also be in a position to go deeper in the understanding of the network given to you. For example, can you identify the bastion host in the network? Can you label the fastest end-to-end intra-office segment, the slowest one? How many total LAN segments do you see here? Can you label at least one network where duplex auto negotiation between the networking devices can actually help? And can you also identify the segment where bit error rate tester can be used to measure the bit error rate?